What is it like as you approach the edge of the universe? What lies beyond these stars? Is there any end to the universe? How would it feel to reach the edge of the universe? These are a few questions that sometimes come to our minds, but we don't get any answers. These questions are not as simple as we imagine. It was almost impossible to get the answer to these questions, but now it is not. Yes, you're hearing me right. Now we have the answer to this question, and today we're going to discuss it. Hello friends, and welcome back to Techverse. Today we are going to discuss an exhilarating thing, a probability and a possibility. Today we are going to discuss how it would feel to reach the edge of the universe. So without wasting any time, let us start with our video. Many existential concerns remain unresolved despite our knowledge of the universe. If our universe is limited or infinite, we only know that it is physically larger than the fraction of it that we can see. We don't know whether our universe is the only one in a multiverse, or if it's just one among many. Even in the initial phases of the Big Bang, we don't know what occurred since we don't have enough data to reach a solid judgment. The universe may be infinite, yet we know for sure that it has a limit. Our ability to see distant objects is limited by how far they are in the past, because the Big Bang happened 13.8 billion years ago with an uncertainty of less than 1%. Although light travels faster than everything else in the cosmos, our ability to see back in time is still limited. 13.8 billion years after the blazing Big Bang, we have a clear view of the universe as it is now. There are large areas of essential space known as cosmic voids between the clusters of galaxies we see and the galactic groupings we observe. Spiral and elliptical galaxies make up the majority of these clusters, with the Milky Way forming an average of one new sun-like star per year. To understand how the universe came to be the way it is now, we have to go farther back in time. The universe seems to be less clumpy and more uniform at higher distances, especially on bigger scales. There are more spiral galaxies and fewer elliptical ones, indicating that the population of galaxies has decreased in mass and developed less through time. In general, there are more blue stars, and the star creation rate was higher in the past. There is less distance between galaxies, but the total mass of groupings and clusters is lower in older eras. The universe starts to drastically change as we go farther back in time to earlier and earlier eras. Even at a distance of 19 billion light years and just 3 billion years after the hot Big Bang, we can observe that the pace of new star formation had reached its maximum, around 20 to 30 times that of today's rates. At this moment, a large proportion of supermassive black holes are active, producing vast volumes of radiation and particles as they devour their surroundings. It's been estimated that the expansion of the universe has slowed by around 11 billion years. Although gravity continues to weaken structures, dark energy starts to exert its influence on the expansion of the universe more than 6 billion years ago, making it the dominant force. Although new stars are still forming, the peak of star creation has long since passed, and supermassive black holes are still expanding, but their brightness peaked sooner, with a bigger proportion of them being fainter and inactive than during the early phases of their evolution. Even more dramatic changes begin to occur as we get closer to the edge indicated by the beginning of the hot Big Bang. There was a period when our universe was barely 3 billion years old and star creation was at its pinnacle. The universe had just 0.3 to 0.5% heavy elements at that time. It was just 1 billion years old when we arrived at 27 billion light years distant. The pace of new star formation was around 1/4 of what it would be at its peak later on. The normal matter's fraction of heavy elements drops abruptly with time, from 0.1% at 1 billion years to barely 0.01% at roughly 500 million years. This is a dramatic drop. Rocky planets may have been impossible in these early conditions. There are no elliptical galaxies in the early universe, so the cosmic microwave background would have been much hotter. It would have been infrared rather than a microwave, and every galaxy in the universe should be young and full of stars. Going back farther than this is beyond our present capabilities, but observatories like Keck, Spitzer, and Hubble have already begun the journey. We begin to encounter the first edge of the universe at a distance of around 29 billion light years or more, which corresponds to a period when the universe was 700 to 800 million years old. Our assumption that space is devoid of light-blocking materials like dust or neutral gas makes us overlook the fact that it is, in fact, transparent to visible light. However, the early universe was full of neutral gas and hadn't been completely ionized by the ultraviolet light from these stars since there hadn't been enough stars produced. So much light is absorbed by neutral atoms that the universe only gets completely re-ionized when a sufficient number of stars have arisen. Due to the edge of what we can see in our familiar wavelength range, infrared observatories like NASA's planned James Webb are critical to our understanding of the early universe. Approximately 550 million years after the Big Bang, we hit the reionization boundary, at which distances greater than 31 billion light-years result in most of the universe being transparent to optical light. Gradual and uneven, the process of reionization resembles a jagged, porous wall in many respects. While certain portions of the universe begin to reionize far sooner than others, Hubble's most distant galaxy is an example of this early reionization. Stars and galaxies must have existed, even though our modern instruments cannot detect them. Even the furthest galaxies we've discovered exhibit signs of prior star generations, and they're already luminous and huge. Despite the limitations of our present telescopes, we may still detect indirect evidence of star formation. Light emission from hydrogen atoms, which happens exclusively during star formation, ionization, and the subsequent recombination of free electrons with ionized nuclei. We now have only indirect evidence of this characteristic of early star formation, which tells us that the newborn galaxies were about 180 to 260 million years after the Big Bang. We may discern the earliest clues of these proto-galaxies' existence buried in the data at a distance of between 34 and 36 billion light-years distant. There's a lot of hope that James Webb will be able to observe these galaxies up close, even if our existing telescopes cannot. The earliest ionization areas of space in the universe may have existed far earlier than that. If we can look back so far, the very earliest stars of all are projected to appear between 38 and 40 billion light-years distant, which corresponds to time frames between 50 and 100 million years after the Big Bang. Big Bang radiation and neutral atoms were all that existed before that point in time. Additional edges of importance may be found going back much farther in time. A human eye would be able to see the radiation from the Big Bang glow red, much like a red-hot surface at 44 billion light-years distant from the Big Bang. 3 million years after the Big Bang, we arrive at this point. It's a journey that takes us 46 billion light-years back to a condition known as the Hot Big Bang, when protons and neutrons, as well as the first stable forms of matter, were formed. Every particle and antiparticle in the universe may be generated from scratch in the primordial soup of our universe at this point. This high-energy soup, on the other hand, remains a mystery. Cosmic inflation's initial beginnings are unknown to us, but many of its predictions have been validated indirectly. As far as we can tell, the edge of the universe is only visible from our vantage point. From there, we can view back 13.8 billion years in all directions, depending on where in space-time we are. Our cosmic horizon extends from the Big Bang out to the boundary of transparency of the cosmos, which includes the boundaries of galaxies and stars. There will always be a basic limit to how far we can gaze with our telescopes. The amount of time that has transpired since the Hot Big Bang is not limitless, even though space itself is. No matter how long we wait, there will always be an edge to our vision. So, here, we are done with our video. Let us know in the comment box if this video has fascinated you guys about space. How many of you would like to visit space in the future? I estimate many of you. Okay, if you guys liked our video, please like and share it with your friends, and make sure you subscribe our channel to watch more videos like this. Thanks for watching.